Hello there. Today we'll be doing top k frequent elements. This is a pretty fun problem. Let's check it out. In this particular problem, we are given a list of numbers and we need to find the two most frequent items. So we can solve this by sorting because we're doing this n log n time. And so all we need to do is count every element, put them in the hash map, get the count, and then sort by the count of in our dictionary. All right, so let's try that. So let's go. So for num in nums, hash set num plus equals 1, and then we're going to just return the sorted of our hash set. We're going to use our key is equal to hash set dot get, and I'm not sure exactly, right, we need to set reverse equals to true. Then we're going to take the 0 through k elements. Let's submit. Okay, pretty good answer. This was very simple, wasn't that? So let's take a look at the time complexity. So on the worst case is n log n, which is happening every single time, and we're going through this array twice. First time you creating the dictionary, and the second time sorting it. So this is going to take O of n space as well. Something else that we could do is bring down our worst case to O of n. However, the average speed is much slower because the way we're going to do it is to create number of frequencies possible, so by the length of the nums. So, and we're going to go in reverse, but on all likelihood, we're not going to have 6 ones in the average case. So this is going to be much slower than this by doing it n log n. But let's check it out anyways. Also, we are doing this. We need to do this multiple times to get all the items in proper form. So yeah, it's gonna take a while. Okay, let's do it. So let's set our count to equal to counter of nums. So what this is going to do is get nums and the times seen. And the next thing we need to do is get the number of times seen and the number. Then lastly, we're going to go from reverse and insert every item into times seen frequency, like so, and insert them into a list of numbers that has a certain frequency. Let's say there was a frequency of 3s and 4s 5 times, 3 and 5 3 times, and that's all the numbers here. Of course, yes, there we go. So let's just do this and find out how poorly this performs. Okay, here we go. So frequency is equal to an empty array for I in range of length nums plus 1. Then we're going to fill in the frequencies as in this case here. So results equals empty array, and sorry, not that's a little bit too early. So for num and time seen in count.items, frequency dot counted dot append num. So this is how we finish up this particular bit. Of course, as you can see, this is not ordered yet. So this is currently looking like this. And now we can create our results by reversing the items. Frequency is basically the length of nums as well. So anyways, so now we're looking at every item at that particular frequency and returning and appending the numbers inside that frequency until the length of results is equal to k, and then we return the result. All right, let's check it out. Time seen. Alright, so as you can see, it's much slower and it's much more memory intensive because we're using an array that is much larger than we actually need, because as you can see, a lot of these frequencies are completely blank. Let's say 6, no, there's nothing there. 5, there's nothing there. We're checking every single frequency. There's just nothing there. It is I don't know. But it is the worst time is O of n, and here we are. So I think this is a creative use of arrays and understanding of arrays, and the way we could somehow bring the worst time down to O of n. And you know, this is like 2n if you think about the space usage, because we're creating the frequency and we're splitting the numbers in list in all the frequencies. And we're creating counters 3n and so on and so forth. We can also count the number of times we've created array. So we're going to do this array once, we're going to do this twice, we're going to do it a third time. This is 3n, and so on average this is much slower. Can we skip the frequency? Can we move on from the time seen to this num? The answer is no, because we need these to go in reverse. We can't just go in reverse and counter. I mean, we have to sort it then, and that's basically the previous solution that we had using the dictionary. Another solution would be to use a heap, but that's not one of the concepts that we're going for in this particular problem, and we'll learn more about that later. So I think we've gone through a lot of material today regarding arrays and heaps for this particular problem. I hope you enjoyed the video. Like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.